Good morning, students, and welcome to your math distance learning class. Today we are going to be having a doubt clearing session by me, Ms. Ruchika. So I welcome you all to this session. And we'll be solving some of your doubts. So we'll begin by taking up 3 questions. So let's get started. Okay, welcome students. So let's start with the first question for today's doubt clearing session. And first I'm going to be reading this question loud and clear for you. So let me start with that, and I will also highlight while I'm reading the important parts of the question that we are going to be using while we solve this question. Okay, so from the top of a 7-meter high building, the angle of elevation and from the top of a tower is 60 degrees and the angle of depression of the foot of the tower is 30 degrees. So we are given here 3 things. One is the height of the building, next is the angle of elevation and the angle of depression. Let's see what we need to find here. So we need to find the height of the tower. So as you can see here very clearly in the figure that I've provided you for this question, you can see that I have labeled it with A, B, C, D and E. So let me write down here now, looking at the figure, what is given, what we need to find and what concepts we'll be using. So I'm sure you must have understood that this question is from applications of trigonometry and that we are going to be using the concepts of angle of elevation and angle of depression while we are solving this question. So let's get started. So the first thing given is height of the building and how much it is? It is 7 meters, and I'm sure that from the figure you can very well clearly see that CD here refers to the building. Yeah, so this CD is of height 7 meters, building. Second thing is angle of elevation, and while I was reading, I'm sure you must have seen that this is also given to you as 60 degrees. So from the top of the tower, from the top of this tower to the top of the building, this angle of elevation is 60 degrees. So angle ACE, let me write here, angle ACE from the figure is your angle of elevation. So whenever it is angle of elevation, let me remind you, you need to increase your eye level. You need to watch on the top and you need to move your neck a little bit so that you can elevate it, so that you can increase it and you can mark the angle of elevation. Next thing which was given to you was angle of depression. So how much is this angle of depression as mentioned in the question? It is given to you as 30 degrees. And very well you can look at the figure now and you can make out that this angle of depression is going down. It is going from the foot of the tower to the top of the building. So this angle is 30 degrees. So two things we have got. We have got the height of the building, we have got the angle of depression, and what we need to find in here, we need to find height of the tower. And once we will be solving this question, once we'll be using this figure a little bit more, you will get to see that the height of the tower, let me represent it with a capital H, is going to be the length of AB. Yeah, and because the unit is given to in meters, so definitely this height will be coming out in meters. So let's get started. Let's apply the rules of trigonometry applied here for this question and move on to the next slide where we solve more on this part. Okay, so let's get started with the solution. Let me highlight a few points before we start to actually solve the question. So here you see AB is going to be equal to EC, which is going to be 7 meters. And also AB is your given building, which is of height 7 meters. And CD is your tower, whose height we need to find. So let me take the height of the tower as h plus 7 now. H plus 7, the unit is going to be same, that is meters, because AB and CE are equal, so the total height of this tower will definitely be h plus 7. So if we get small h, we are done. We will be able to summarize our solution. Now let's see what two other things are given. One is angle of elevation, one is angle of depression. So let's use them one by one. So I'm considering in the right triangle, because it is trigonometry, we are going to be using right triangles. So let's use the right triangle ADE. Now the ratio which is given to me, the angle which is given to me is 60 degrees. So can you tell me which ratio are we going to use? We need this opposite side H, and the adjacent AE is what is going to be equal to BC. So can I write tan 60 degree as DE divided by AE? Yeah, that is one thing that we are going to be using, and we already know the values of these angles. We know tan 60. DE is as, let me write it as H, and AE is definitely going to be equal to BC. I'm sure you know the reason, because that is a rectangle. So now I'm substituting the value. This is square root of 3. So I get from this part that BC is going to be equal to H divided by square root of 3. So one value I've received from the angle of elevation. Let's move on to the next slide, where we see what we can get from the angle of depression. Okay, so let's continue now from the last slide. So in the last slide, we had got that BC is equal to H divided by square root of 3, and there we had used the property of the angle of elevation. We had taken the trigonometric ratio of tan. So tan 60 is what we had used. Now let's go to the next right angle triangle, and this time we are now going to be using the concept of angle of depression. So I'm now going to be taking the right triangle ACB. Okay, and because we know angle of depression and angle of elevation are equal, so angle of depression EAC is going to be equal to the angle of depression ACB. So I'm taking ACB angle and the same ratio tan. So tan of 30 degree is what I'm going to be considering. And as we know, tan is opposite over adjacent, that will be AB divided by BC. So let's substitute the values. I hope you can recall that tan 30 is 1 over square root of 3. AB is what we are given in the question. That's the height of the building which was given, 7 meters, and BC is what we don't know. So let's cross multiply, simplify. And when we are going to be doing that, we get the value of BC. So BC has come out to be 7 square root of 3 meters. That's what we've already got. And now that we have from the last part BC as h over square root 3, and now that we've got actually the value of BC, so we can use equation 1 and 2, and from there we can easily get the value of h. I'll give you a minute here to try and solve and give me the value of h, and let's check our answer in the next slide. Okay students, welcome back. What did you get your value of h as? I'm sure you've got the same value as mine. So BC was h square root of 3 from the first equation, and this was exactly equal to the value 7 square root of 3 from the second equation. Now since both of these are equal, we can just cross multiply and get our value of h from here. So this is same as by 1. So when I cross multiply, I do this thing, and that is where I will be getting the value of h. So h is 7 square root of 3 into square root of 3. So how much is h now? Yeah, I'm sure you have reached to the correct answer. H has come out to be 21 meters. Now a question for you. Are we done? Have we got our answer? Yeah, not yet. So what is missing? We had to find in the question the final answer as height of the tower. So let me just now summarize the last part. We had to find the height of the tower. So the tower is the taller tower here. That was your AC. And if you look at the figure once more, you would realize that that AC that we want, the height of the tower, is nothing but h plus 7 meters. Yeah, so we are still left with the final solution. Let's substitute the value of h here and reach to our final conclusion. Let's summarize our answer now in the next slide. Okay, students, so now we're on the last part of the question where we just summarize a solution. So let's summarize what we learned in this question. So in this question, we had to find the height of the tower. And as you see in the figure, back again, I would remind you that the height of the tower here is equal to the height of CD, which is h plus 7 meters. So I'll just substitute the value of h that we got in the last slide. That was 21. So your final answer for the height of the tower is 28 meters. So many times students do this mistake. They just leave the answer at the step where you get your h as 21 and you forget this last and the most important step. So don't do this mistake, so that you are able to get your 100% in the answer. I would urge you to completely read the question nicely, break it down into what is given, what you need to find, and then proceed step by step. I hope my elaborate explanation of the question helped you to understand it well, and I've been able to explain and clear out your doubt for this question. So that completes this part. Let's move on to the next question, question number 2, that we'll now see in the next slide. Solution. Okay, so V1 is equal to 2 by thirds V2. This is the relationship we had written where V1 is the volume of the cone and V2 is the volume of the hemisphere. So let's put in the formulas, let's substitute them. I want you to recall the two formulas while I'm writing here for you, and then we'll try and form a relationship from simplifying this expression. So the volume of the cone, as you would have recalled, is 1 by 3 pi r square h, and the volume of the hemisphere is 2 by 3 pi r cube. I want you to recall here that a hemisphere is half of a sphere, so its volume is also half of the volume of the whole sphere. Here, capital R is the common radius of the hemisphere and the cone, and h is what we need to find, that is the height of the cone. So let's simplify this. If there is something that will cancel, let's do that and then find a suitable expression. So pi and pi is the first thing I cancel. Then 3 is also common, it cancels from both sides. And here I have r square on the left and r cube on the right. So power 2 of r would cancel and there is just one r which is going to be left here. So from the left side, if I cancel the common things, I'm left with 1h. On the right, 2 with 2 will give me 4 over 3. And there is one r left here after cancellation. So r square is gone and here r square is gone. So one r is still remaining. So this is one part of the solution where we have got our value, or we have got a relationship between h and r. Now for the second part, we need to find the total surface area of the toy. So if you go back to your figure, you would see that the toy is made up of two solids. Yeah. So we are going to be taking the curved surface area of the hemisphere, which is at the bottom, and we are going to be adding the curved surface area of the cone. When we add these two things, what we are going to be getting is the total surface area of the toy. So let's now find this in the next slide. Okay, so in the last slide, we got the relationship h is equal to 4 by 3 times capital R. Now, if you read the question carefully, then R was given to you, that's 21. So we can simplify, substitute the value, and we will get the first part of the solution, that is the value of h. So you simplify and you will get h as 28 centimeters. So we are done with one part of the question. I hope it is clear to all. Now, if we move to the second part, we need to find total surface area of toy, for which we will need the curved surface area of hemisphere, and we'll also need the curved surface area of the cone. So I want you to again remind yourself of the formulas for these two. What is the curved surface area of hemisphere? What is the curved surface area of cone? So let me remind you here, for the hemisphere it will be just this curved part. So it will be 2 pi r square. And for the cone it will be the curved part on the top, which is pi r L. Now your radius is going to be capital L because we share a common radius between the hemisphere and the cone. So can you tell me what is the only thing that you don't know in this expression in order to find the total surface area? I'm sure you must have observed that is your L, or your slant height. So now we need to just find this L, and if we get L, we can just substitute all the things. In the question, it was already mentioned, you need to take pi as 22/7 for your calculation. So once we get our L, we are done with the solution. So for L, let me go to this right angled triangle. You know this is the right angled triangle if I name it as, say, A, B, and C. So for a right angle triangle, this side AL, which is your hypotenuse, is nothing but your slant height. Now, whenever I say the word hypotenuse, the first thing that should come to your mind is the Pythagoras theorem. So to get this L, let me write here with blue. Can I say, because it is a right triangle ABC, this is your hypotenuse AC, that is going to be equal to the square root of h square plus r square. And all of these things now, h we know is 28, r we know is 21. So I can easily get my L from here. Let me substitute. 28 square plus 21 square. I want you to be now solving this expression and to give me the value of L. Okay, so in the last slide, we tried and solved, and we tried to find the value of the slant height of the cone, which is L. So I'm sure you all must have got the slant height correct. So when you solve that expression of 28 whole square plus 21 whole square, you would have got 35 centimeter as the slant height. Okay, now that we have the slant height, the last part of the question is the total surface area of toy. Let's just plug in the values here. So it will be pi r L plus 2 pi r square. So I can take pi r common here just to simplify, and I can write this expression as this one. So let's put in the value. Remember, it was mentioned in the question already that your pi needs to be taken as 22/7. So don't forget the correct value. Plug in everything that you've got here. And now you can easily solve this, and because it is area, the unit will be centimeter square. Very important not to forget. I would want you to now simplify this. You can do your simplification a little more easier by cancelling out the common terms. This will make your answer very easy. So 66, 35 plus 42. So just multiply, simplify, and you will get your final answer. It will be coming out as, let me do the calculation for you. So when you use your calculator and simplify it, it will come out as 5082 centimeters square. So that completes our answer. So the total surface area of the toy also we have got now. I hope this question was pretty clear. We did it very slowly with all the steps, and explanation was given to you how to reach to the correct answer. I hope this answered your doubt. Okay, students, now let's solve the last and final question of our today's doubt session. That is question number 3. I will first read out the question for you as usual. So here we need to prove the following trigonometric inequality which is given to us. So it is like a question which is based on trigonometric identities, as you must have observed by now. So I will read the left and right part of the identity that we need to prove. So on the left hand side we have tan A divided by 1 minus cot A plus cot A divided by 1 minus tan A, that is going to be equal to 1 plus tan A plus cot A. This is what we need to prove. We are not right now sure. We need to just show the steps and prove that this is going to be true. So for that, we will use the concept of trigonometric identity. And since it is a proving question, we'll start from one side and show that it is equal to the other. So let's start the question with the left hand side, and we will prove here that both the sides will come out to be equal. In this, we will use the reciprocal identity of trigonometry, and we'll be using the formula tan A equal to 1 by cot A and cot A equal to 1 over tan A to simplify and reach to our answer. So let's get started. Okay, so let's start now the question. So I'm beginning with the left hand side, and as we decided, we are going to be using trigonometric identity here to simplify and put it into one trigonometric ratio. So what I'm going to be doing now is I'm going to be replacing everywhere where we have cot A with 1 over tan A. So I'm using the reciprocal identity. So this is what you will be getting when you do that. And we are going to be now simplifying this further to reach to our right hand side. Let's see how. Okay, so in this part, I will be first taking the LCM to simplify. So that will give me tan A over tan A minus 1 over tan A. And this part is as it is. So 1 over tan A times 1 minus tan A. Now we'll try and make the denominator same so that we can take the LCM in the next step. And for that, what I'm going to be now doing is this tan A I will take on the top. So it will become tan square A over tan A minus 1. And as I told you, I want my denominators to be same. So 1 minus tan A is already there, and I need to change it to tan A minus 1. So when I do that, we need to do what? We need to put a negative sign here. So negative 1 over tan A comes. Now I'm sure you are able to notice that the two denominators are equal. Both sides it is tan A minus 1. So that means we can successfully take it as the common denominator, as the LCM. And now on the numerator, I'm just left with tan square A minus 1 over tan A. Again, I'm going to be taking the LCM on the top again once more. So that will give you tan cube A minus 1 over tan A multiplied with tan A minus 1. Now, as a very important next step in the numerator, I will be using an algebraic identity. And I'm sure students, you will be able to recall that we are going to be using here the algebraic identity a cube minus b cube, which is equal to a minus b times a square plus b square plus ab. So let's go ahead and use that. And why I'm doing this process, you will get to know just in the next slide. So I'm just now plugging in the formula. So here you get tan square a plus 1 plus tan a. Let me write it here. Okay, great. Now let's see why we have done this step. And I'm sure you will be very clear to see that this term and this term in the numerator and denominator gets cancelled. And that is the basic reason why we use this algebraic identity. So let's move on to the next slide, and there we are going to be concluding our solution. Okay, now so final and last step of the question. So I'm again beginning with the left hand side, and when we stopped in the last slide, we stopped at this value tan square A plus 1 plus tan A whole divided by tan A. Now, as you can see, there are 3 terms in the numerator, only 1 in the denominator. So let's divide them and distribute 1 by 1. So that gives you tan square A over tan A plus 1 over tan A plus tan A divided by tan A. So what are you getting now? Let's see. So this term, 1 tan value is going to cancel. You're just left with 1 tan A. And then 1 over tan A. Again, can we use reciprocal identity? So we are going to be getting cot A. and here both of them cancel, so just left with 1. Now compare, is it the same as your right hand side? Definitely it is. So that tells us that left and right, both sides are equal. And when both of them are equal, we can easily say that yes, we are done. We have verified the solution. So hence proved this trigonometric identity. That completes the question. Let's summarize now in the next slide. Okay, so let's summarize what we learned in this question. So in this question, we had used the trigonometric identity. We started with the left hand side, that was tan A over 1 minus cot A plus cot A over 1 minus tan A, and we solved and simplified this left hand side till we reached the right hand side, that was 1 plus tan A plus cot A. So from the left we moved to the right hand side by using the identities, by using the trigonometric expressions, and we were able to prove. So therefore we completed the solution, we proved the trigonometric identity. So I hope the 3 questions that I took today for you, I solved your doubts clearly and you understood the correct answers. And that is all for the session today. Thank you for joining and see you in the next session. So thank you very much for joining me in today's doubt clearing session with Unacademy. So we covered 3 very important questions, and I hope that I made your doubts cleared with all the steps and explanation that I provided. So that will be all from my side. Bye students. This is Miss Ruchika signing off from today's math class.